All right, you are now watching Unit 1, Scale 10 is constructing the median of a triangle. So our essential question is, how do we construct the median from a given vertex? Okay, so example 1, construct the median from vertex B. So vertex B is where you're starting from, so that's our start point, to AC. So we're going to connect to side AC. So really quickly off to the side, what is a median? Okay, so what is a median? A median is the line connecting a vertex of a triangle to the, what do you think of when you hear median? Median, you should think middle. So middle means midpoint. So connect the vertex of a triangle to the midpoint of the opposite side. Okay, so key point here is the opposite side of the vertex. So if I'm looking at this triangle, the opposite side of vertex BC would be AC. The opposite side of vertex A would be, draw a line to the opposite side would be BC. And then the opposite side of angle C would be side AB. But we want to start at angle B, and we want to basically, we're going to cut side AC in half using, how do we cut things in half? Using the perpendicular bisector construction, okay? So I'm going to go ahead and start by making sure that our median is going to be the line that connects B to the midpoint of side AC. Okay, so we want to find the midpoint. So step 1 is find the midpoint of AC. Okay, and we're going to do that by using the perpendicular bisector. Okay, so we're not going to do what we did with the altitude. We're not going to swing that smiley face arc first and then connect to make our altitude, because if I connect to make my altitude right now, it's going to hit here, and is this going to be the midpoint of side AC? No, it's not. So the median is not the same thing as the altitude. The median, we have to find the midpoint of AC. So our median is going to sometimes be a slanted line, not always perpendicular and not usually perpendicular. Okay, so we're going to go ahead and construct the perpendicular bisector of side AC. I'm going to open up the compass more than halfway. Swing it up, swing it down. Start on vertex C. Up, down. All right, we got our top and bottom points. We're going to go ahead and connect. Okay, so now that we've made our perpendicular bisector, we have not yet drawn in the median. So first and foremost, identify where the midpoint D, I'm going to call it D. So D is the midpoint of side AC. Okay, and now the median is going to connect vertex B to the midpoint. So now our median is actually going to be the line that connects B to D. So I'm going to do that in a highlighted color so that you can see that this line, BD, is the actual median, not the perpendicular bisector. The perpendicular bisector is just used to create the midpoint, and then you have to connect the vertex to the midpoint to create the actual median. So BD is the median of triangle ABC. Okay, so there's one thing we can draw a conclusion about, and because that is true, then D is the midpoint, which we already stated. But we can also say that AD, what two segments are congruent then? AD is a congruent segment to DC. Okay, so that's another conclusion we can draw by this median being drawn in. Okay? All right, next one, construct the median from vertex A of triangle ABC. So if I'm starting with vertex A, we're going to start here, okay? And we want to connect the vertex of angle A to the midpoint of BC. So the opposite side I'm going to highlight in this case, is side BC. So our median is going to connect A, so angle A, to the midpoint of the opposite side in this case, which is BC. So we have to find the midpoint of side BC. Okay, so we're going to do the perpendicular bisector of side BC by placing your compass on the one endpoint, B, and then place it on C. Again, always remembering to use the same radius hole. So if you use the inside one, always use the inside, or vice versa if you use the outside. Now connect your intersection points. There's your perpendicular bisector. So a big mistake that students make is they stop there. And they're like, oh, that's the median, I'm done. But that is not true, because this is just used to create your midpoint. We'll call it D again. So let's say that's the midpoint. And then the median needs to be connecting the vertex A to the midpoint D. So I'm going to go ahead and use the side of the compass to connect those two. Okay. And now I'm going to highlight in a different color just so you can see that AD is the actual median. So down here, AD is the median of triangle ABC. Okay, so summarize each step in the construction. Step 1 is we're going to find the construct the perpendicular bisector on the side opposite of the vertex angle given, and this is used to find the midpoint. And then step 2 is connect the given vertex angle to the midpoint of the opposite side of triangle. Okay, so construct your perpendicular bisector on the opposite side of the given vertex angle to find the midpoint, so that's very important. And then connect the vertex angle to the midpoint of the opposite side of the triangle. Okay, let's see what's on the next page. Example number 2. Okay, so just a couple more practice problems that are with different shapes. So it says, example 2, construct the median from B. So B is our starting point, wherever it says from, to AD. So we're going to connect from B to AD. So what we're going to want to do is find the midpoint of AD. So looking at this picture, I've got B, and I want to construct the median, or the line that connects angle or vertex B to the midpoint of AD for our median line. So we're going to bisect side AD. Okay, so that's our step 1, bisect side AD. So I'm going to go ahead and highlight the opposite side that's getting bisected. Okay, and then let's go ahead and do the perpendicular bisector. So go ahead and do this one on your own. Should be getting pretty good at this one. Okay. Okay, so we've got our midpoint we have to label, A, B, C, D. Let's call this point E. That's the midpoint of AD. Okay, and then our median is going to again be the line drawn from B to the midpoint of AD. So I'm going to go ahead, connect from E to B, and there is our actual median. So I'm going to highlight that in pink. Okay, so this is our median. And by doing this, we're actually creating two congruent segments down here too. So ED is congruent to AE. So ED is congruent to AE. Okay. So, and we can also say that EB is the median. And in this case, this is another trapezoid. A, B, C, D. I mean, this is another shape that's not necessarily a triangle. So it doesn't always have to be a triangle that you use to construct a median. It's just always the connection of the given vertex to the midpoint of the opposite side of any shape. Okay. So the next one, construct the median from D to AB. So now we've just got an inscribed triangle, and it's inside of a circle. So we just have to kind of ignore that circle part and realize that we're just connecting and making the line that connects from point D to AB. And in this case, you can see that we have it already drawn in, since AB is the diameter, because it connects from the left side of the triangle to the right side and goes through the center point there. But if we weren't given this center point, let's just make sure that when we do our perpendicular so when we do our perpendicular bisector, you'll see that it's going to go through that point C. So we're going to connect from point D, which is our starting point, to the midpoint of the opposite side. In this case is side AB. So we're going to bisect side AB. Okay, so there we go. You can see it's going to go perfectly through point C, and then our median is going to connect from D to point C. Okay, so our median is going to be there. I'm going to highlight it in pink again. And there's our median. Okay, so in this specific picture, A to B, like we talked about a couple seconds ago, AB, if it connects from one side of the circle to the opposite side and goes through the center point, so C is the center of the circle, then AB is the diameter. Might be a while since you've heard that word, of the circle C. So when we construct the median is actually a point of the line that connects a point on the outside of the circle to the center. So if you notice, from here to here, DC is actually the same distance as A to C, and from C to B. So we can also make a conclusion over here is that AC is congruent to CD, or DC, is also congruent to CB. Why is that true? These are all, do you remember what those are called? Those segments that connect the center to the outside is called the radius. And the radius, they're all radii, which are half the diameter. Okay, so another name for the median of this triangle is actually the median, DC, is the radius of circle C, because it connects a point on the circle to the center of the circle. Okay, so just some connections back to a circle and some names of line segments drawn in on a circle. right, so go ahead and try some practice problems.